today we're looking at inverse and one-to-one functions. Okay, so what is an inverse function for one thing? Well, basically in layman's terms, the inverse function, or let's call it the inverse function, undoes a function. Okay, so that's in layman's terms. Of course, that's not really a definition, but so if you've got like f of a equals b, for instance, that means if you put in b into the inverse, you get a. Okay, so these are kind of like, this is what that happens with the inverse function, right? The official definition, and what one we're going to use a lot, is if f of f inverse of x equals x, then this is the inverse. Okay. This also means that f inverse of, let me rewrite it this way, f inverse of f of x equals x. Okay, so it's basically whatever you put in, you get back the same thing if it goes through the function and the inverse, because it undoes the other function, right? So let's take a look, and this is the notation. For a function to have an inverse, it needs to be 1 to 1. Okay, that means for each y value, there's only one x value. Okay, so it needs to pass horizontal line test, we call it. Okay, so if you look at the first function, I can draw a horizontal line and it hits 1 point everywhere on the function. That means this function is 1 to 1 and it has an inverse. So you can say 1 to 1. Okay, this function, which is like y equals x cubed, does have an inverse. Alright, and this one here is also passes the horizontal line test, so it is 1 to 1. So it does have an inverse. Next one does not. Okay, does not pass the horizontal line test, so it does not have an inverse. We call it many to 1, I guess. But the main point is it does not have an inverse, unless you restrict the domain. Okay, let's call it not invertible. Here's a parabola, and unless you restrict the domain, it does not have an inverse, because it fails horizontal line test. Okay, no inverse. Many to 1. And this one, this is actually not a function at all. Okay, this original thing is not a function. So you can't call it a one-to-one function if it's not a function at all. It fails the vertical line test. This one passes the horizontal line test, so it is 1 to 1. And it has an inverse. This one fails it, so it's many to 1. Does not have an inverse. Sketch your own one-to-one function. Well, it's just any function where you can't draw a horizontal line and hit two values, right? So just as long as you could do something where you go up and then come down again. So it has to be basically always increasing or always decreasing or staying constant or something. So you can draw any old function you want. Okay, you can draw something like that, for instance, right? As long as everywhere you draw a horizontal line, you only hit 1 point. So there's a 1 to 1 function. Okay, 1 to 1 function, for every x there's only one y value, and for every y there's only one x. The function passes the horizontal line test. Okay, a function is 1 to 1, then it has an inverse function, denoted by this. If a function has an inverse, f of x, then f of x is, we'll say, invertible, or well, we could say 1 to 1. This is 1 to 1, it's not 1 subtract 1, right? So basically f of x equals, now this is a two-way implication sign, right? If and only if. This is what we say the symbol is. F of x is 1 to 1 if and only if f of x has an inverse. Okay, so because we got this two-way arrow thing, this also means you read it the other way. F of x has an inverse implies f of x is 1 to 1. Okay, let's take a look at the next page. Sometimes we have an inverse to be a function. We sometimes restrict the domain. Alright, let's look at this first. Okay, so g inverse of 1, negative 1. So that just, this is like, what is the x value when the y value is negative 1 in the g function, right? So here we have g of 0 equals negative 1. G of 0 equals negative 1. That means g inverse of negative 1 equals 0. Right? And over here, g inverse of 1. Well, there is no 1 here in g, so this is undefined. And here we have f inverse of 0. So look for the y value of 0 on f. So that'll be right here. So that equals negative 1. Okay, so you keep going like this and fill in all this in. Let's do one more together. So this you do h of 1. H of 1 is, where's h? H of 1 is negative 1. So now we do g inverse of negative 1. That's equal to 0. Okay. Then we do f of 0, and f of 0 is just 1. So you just do it in 3 steps. It's pretty easy. Okay, this is a parabola. Is it a function? Yes, it's a function. Let's graph it. 2, 3 is the vertex, and it's going to look like this, right? It's just a parabola like that. So yes is a function. This is what the graph looks like. Is the equation 1 to 1? No, it fails the horizontal line test. All parabolas do unless there's a restricted domain. The domain is all real numbers for this regular function. Restrict the domain so the function is 1 to 1. We can do that in many places. But the most common sense is to restrict it right here. X is greater or equal to 2, or you could do x is less than or equal to negative 2 if you want. The range of this restricted, or the entire function, whether it's restricted or not, is y is greater or equal to 3. Different color, sketch f of x with restricted domains. So I'm just going to draw over it. And the inverse, now for the inverse, you basically could swap all the x and the y values. So this point here is 2, 3, so 3, 2 is going to be on your inverse, which I'll do in blue. This point here on the original function is 3, 4, so 4, 3 is going to be here, and there you go. That's the inverse. Okay, it looks like that. Domain of this function you can obviously see is x greater or equal to 3. So notice that it's the same as range of f of x. It's always going to be like that for inverse functions. The range of the inverse, the range is y greater or equal to 2. As you can see, it's the same as the original function. Calculate or find the inverse means, let's find this inverse. So let's swap the x and the y values. X equals y minus 2 squared plus 3. That's x minus 3 equals y minus 2 squared. Okay, let's take the positive square root. If you take the negative square root, you'll get the inverse of this red part here. And then let's add 2. So y equals, actually you should use this notation at the end. F inverse of x equals root x minus 3 plus 2, which is the equation of the square root function right here. Okay, next we're going to confirm that f of f's inverse of x equals x after we find the inverse, of course. Okay, let's find the inverse by swapping the x and the y values. Then we just multiply here, so we have 2xy minus 3x equals y. Let's get our y's to one side. And then we factor out the y. So we'll have f inverse of x equals 3x over 2x minus 1, and then verify that it's an inverse. We can do that. So let's do that different color. Okay, f inverse of 3x over 2x minus 1, or actually that is the inverse, so let's just do this. Yeah, f of that is, so we take 3x over 2x minus 1 and substitute to this function. Okay, and multiply numerator and denominator by 2x minus 1. And we get 3, that's 9x. 9x over, so that cancels and we get 6x minus 3 times 2x minus 1. So that's 9x over 6x. Is that going to be a minus, or should that have been a plus somehow? We'll see. 3 minus 6x. Oh, okay, that makes sense. Plus 3. That gives us 9x over 3, but the answer is supposed to be x, so we must have made a mistake somewhere. Yeah, this is the correct inverse, I think. Maybe I got the numerator wrong here. Oh yeah, this is just x right here. There's not a 3 in front. Sorry about that. So it's just like this, and that should be just a 3x in the numerator. This should be a 3, and it gives you just x. Okay, so it basically proves that this function is the inverse of this function. Okay, let's just do one more. Let's do number 5. We got f of x equals this, and g of x equals this. Find a and b such that f of g of x equals x, or basically you could have also said g of x is the inverse of f of x, find a and b. That means the same thing, right? It means it's the inverse. So just sub it in. So 3, so let's write it out a bit more clearly. F of g of x equals, take the g and sub it in, we got 3 ax plus b minus 2 equals x. Okay, by this, so that equals 3ax plus 3b minus 2 equals x. Now if you look at this closely, we're going to do a lot of this later in the course. On the right hand side, I can write as 0x plus, not 0x, 1x plus 0, right? So then you can equate the coefficients, 3a, right? And on the right hand side, we got a 1. That means 3a equals 1, and a has to be 1/3. And if you look at the other part, 3b minus 2 has to be equal to 0, so b equals 2/3.